All right, if you haven't joined the Pear Deck, make sure you do so. We're on lesson 2.1. So today we will investigate how the mass of an object affects force and velocity changes. And then we are going to conduct an investigation on the relationship between force, mass, and velocity. All right, so for our first activity, we're going to do our warm-up like usual. You guys are going to read the new message from Dr. Gonzalez. So we have another email from her. And then you're going to answer the question about how the mass of the pod could have affected docking with the space station. All right, so here is our message from Dr. Gonzalez, and I will read it for you. You can follow along if you would like to, or read it yourself. It says, "Thank you for sharing your models and explanations. This information is very helpful. We analyzed the thruster data from the pod and found that the thrusters exerted the same strength force as in other missions. Since this pod didn't stop, we'll need to look at another cause. The pod has been collecting asteroid samples and we aren't sure how many it was carrying. Could a difference in the number of asteroid samples explain why the same thruster force caused a different change in velocity? We'd really appreciate your help with this." And so it's going to ask you down there if a difference in the number of asteroid samples, if that could explain why the same thruster force caused a different change. So go ahead, click on this screen in Pear Deck, and it should take you straight to that warm-up. And take a few minutes to do that warm-up. Take another minute or two to finish that up. All right, about 30 more seconds to get that answered. If you are not in the Pear Deck, make sure you are back in the Pear Deck once you get done with that warm-up. All right, so once you get done with the warm-up, make sure you're in our Pear Deck. We are on our new chapter. So this is our chapter 2 question. And so in that email we just got, it said that the thrusters were not the problem. So we're going to look at this chapter 2 question for the next few weeks. It says the thrusters on the ACM pod exerted the same strength force as thrusters on other pods. So why did this pod move differently? Okay, the thrusters on the ACM pod exerted the same strength force as the thrusters on other pods. So why did this pod move differently? All right, so remember, we aren't sure how many asteroid samples the pod was carrying. Now, do you guys think that the number of asteroid samples a pod is carrying could make a difference? And why or why not? All right, so go ahead, put that response in Pear Deck if you are not already. All right, make sure you're responding in Pear Deck. I've only got about 10 out of 18 of you responding. All right, so most people are saying yes. A lot of you guys are talking about either mass, weight, something about the velocity, maybe the direction. Something about it being heavier. All right. So we are going to move on to activity 2. We're going to review the investigation question for today and the details on the next slide, and then we're going to complete the forces on different objects. All right, today we're going to investigate this question. If the same strength force is exerted on two objects, why might they be affected differently? Okay, if the same strength force is exerted on two objects, why might they be affected differently? All right, so if this ball was sitting on a table, how do you think we can make it move? How did we make it move with the plunger? Okay, we hit it. Okay, you hit it with a plunger, you exerted a force from the plunger, you pull the plunger back and let it go. Hit it with the tube thing. All right, so we are going to apply some type of force, all right, with this plunger, correct? We pull it back to a certain length and we're going to apply some type of force. All right, so what we're going to do is we're going to plan an investigation. All right, if the same strength force is exerted on two objects, why might they be affected differently? And so you guys can go ahead and tap on this screen. Okay, tap on that screen. It'll take you straight to Amplify. And you've got your first question right there. Okay, question number 1 says, think about what you already know. Why might two objects be affected differently if the same strength force is exerted on them? And you probably can just copy your same answer from one of the first slides that we did. We talked about the pod mission, and if the same strength of the thrusters was exerted, why would that be different? So think about it that way and answer that first question right there. And so what we're going to do is we're going to kind of walk through this investigation because it would have been a hands-on investigation if we were in class. Let's go ahead and tap on that screen if you have not already. And so what we are going to do for this investigation, I have actually recorded videos for this investigation that you would have done in class. And so we're going to use the launchers to exert the same strength force to see how it affects both a table tennis ball. So ping pong ball is what you can call it. They just call it a table tennis ball. And a golf ball. All right, so a ping pong ball and a golf ball. All right, so here are our supplies, okay? These are our supplies. If you want to follow along and answer some questions in Amplify while we do them here in Pear Deck, you can. I am not so much worried about this part of Amplify. So if you're looking at my screen, I'm not really worried about you filling these answers in. I want you to make sure that you are following along on Pear Deck. So I'm not too much as worried about filling these in right now. So make sure we follow along in Pear Deck and we can come back to those later. All right, so if we're using these objects, so we've got a meter stick over here. We've got our golf ball and our ping pong ball that we are going to exert the same force on. We've got a stopwatch, and then we've got our plunger, our fancy dandy plunger. All right, what are we going to change? So we've looked at independent variables before in our last experiment. What do we change in each test? All right, Zachariah is saying the velocity. What are we changing in each test? Okay, Praveen is saying the type of ball. What else, guys? So I've got velocity, I've got the type of ball. Your amount of force should be staying the same because you're exerting the same amount on each ball. I'm not saying that your answer has to be different from Zachariah's or Praveen's. The red thing is a timer. All right, so what we are changing. What we are changing is the type of ball or the amount of mass that is in the ball, in the ping pong ball and the golf ball. So we're changing the type of ball. Okay. If we are going to exert the same force on the ball, what could we possibly observe using the tools that we have here or the objects we have here? What could we observe as a result of this change if we're using two different balls? All right, one could go faster. Zachariah, you're close when you say the speed. What's another word that involves speed but also includes direction? Velocity, right? So we're going to be observing something with the ball's velocity. All right. So we are changing the type of ball or the amount of mass in each object. And then we're going to observe something with the velocity. Okay. So if each object starts at rest, its initial velocity is 0. Okay. We know that if it's not moving, its initial velocity is 0. Okay, so this means that the object's change in velocity will be the final velocity after force is exerted. If the initial velocity is 0, at the end, the final velocity will be the change in velocity. And we'll talk about that a little bit more. You'll see that more in the simulation that we're going to do later. All right, so remember velocity is speed in a particular direction. So you'll need to find the speed and indicate the direction. You'll need to find the speed and indicate the direction. So we will need to get time and distance of the ping pong ball and the golf ball. We'll need to get time and distance of the ping pong ball and the golf ball. And so to calculate speed, we have distance over time. I'm not sure if you guys have learned this in previous classes or not. You may have learned it in a math class or another science class, but speed is distance, so that D stands for distance, and time. Right, so I've got an example over here. So if you run 360 meters in 60 seconds, you're going to put the distance on the top, so 360 meters, divided by the seconds, the amount of seconds it took you to run that. And so once you calculate that, 360 divided by 60, your speed is 60 meters per second. Right, so if we were talking about the velocity of that, we could say 60 meters per second in whatever direction they're going. Okay, so speed is distance over time. All right, how many trials do you think we should conduct doing this? How many trials do you think we should conduct? Okay, I'm seeing 3. So I'm thinking 3 or more. The videos that I recorded, I actually only did 3. But if you would like to do them on your own to get some more data, you can. All right, so here is how we're going to do our investigation. So I did not have you guys plan out this investigation just because you may not have all the supplies. You may not have a ping pong ball. You may not have a golf ball, but you could do it with other different types of maybe a basketball, maybe a baseball or a softball or something like that. All right, so we are going to watch my videos here in a minute. And so remember, we need to make sure that we hold that spring launcher flat on the floor with one hand and pull the narrow end back with the other hand. Okay, so that stopwatch, we would have done this as partners because somebody would have to apply the force and somebody would have to use the stopwatch. And so I had to make sure I had a friend help me with this. They had to start the stopwatch whenever I applied the force and stop it whenever it reached the end of the meter stick. All right, so these are the videos. I am not sure. I don't think it will show in actual Pear Deck. So if you want to watch the videos together, I still have my shared screen up, and so we can watch them on there. All right, so you need to pay attention to the time. Okay, you need to pay attention to the time. We can fill out our chart together. So the two things that we need for speed. What are the two things we need in order to calculate speed? Somebody let me know. What are the two things we need in order to calculate speed? All right, distance and time. And so we know that speed is going to equal distance divided by time. So we need to be able to write that down somewhere. Okay, so you need to either get a piece of paper or you can actually go and do that in Amplify. Okay, so we are not going to write out the steps here. We are going to use this data table to write out what we observe. We're going to use this data table, so you either need to make your own table or you can do it here in Amplify. This is still on the second tab, the hands-on activity, but it's on that second circle down here. Every time we do an investigation, you need to make sure that you are writing down what you observe. All right, so we are going to have 3 trials, and what I'm going to do is I'm going to put trial 1. I'm going to put golf ball. I'm going to do trial 2 with the golf ball, and then I'll have trial 3 with the golf ball as well. And so below that, I'm going to have trial 1 with the ping pong ball, trial 2, and then trial 3. All right, so if you want to fill out your chart like that, you totally can. I just thought this would be the best to kind of just see them right next to each other. And so what we need to calculate is speed. Okay, so we need to get the distance and we need to get the time. What I'm going to tell you right now is that the distance is always going to stay the same for these trials. Okay, I measured out 3 meters. I measured out 3 meters. And so I'm going to start both of these balls at the 3rd meter and let it go to the end. So you'll be able to see how far it goes. So both of these balls are going to travel 3 meters. And then what we're going to do is we're going to be able to divide it by the amount of time that you see on the stopwatch. Okay, so we are going to calculate the speed of each of these trials. Right, distance divided by time. So we are going to go and look at trial 1 of the golf ball. All right, if you want to look at my shared screen, you totally can, or you could do this on your own because it will allow you to go and press on that video. So I'm going to start with the golf ball on trial 1. All right, make sure you're watching the time. All right, so we've got that time on there. Does anybody remember what that time was? I will actually go here and maybe pause it. All right, so that is it paused. All right, so Ben and Graham both said 1 second, 1.7 seconds. So that is what we are going to divide our distance by. So if you want to go back and forth here between Amplify and my video, you will divide 3 meters by 1.7 seconds. And you can figure that out with a calculator. Either use your phone or use a calculator. All right. I'm not going to calculate that right now just because of time. So if you want to do that on your own, you can. And so I'm going to move on to trial 2 of the golf ball. And I will play it now. All right, what did we see? That is our time right there. So our time is 3.79. 3.79 is our time. All right, so we are going to divide 3 meters by 3.79 seconds. And you can use your calculator to do that. All right, I'm going to move on to trial 3. Hopefully I'm not going too fast. So trial 3 of the golf ball. All right, and that is our time for the last trial. All right, so we've got 1.6, it's 6.5, so 1.65, okay? And we are gonna go and put that into Amplify, 1.65 seconds, and you can figure that out. All right, so for our first trial, we had 1.7 seconds. Second trial, we had 3.79 seconds. And the last trial was 1.65 seconds. All right, I'm going to move on to the ping pong ball. We are still moving 3 meters. But we need to figure out what our time is. All right, so here's the first trial for the ping pong ball. All right, so there's our first trial. We've got 0.79. Okay, so 0.79 seconds. We're going to divide 3 meters by 0.79 seconds. And you can figure out what that equals. All right, for trial 2. Oh, I clicked on the wrong one. All right, that is our second trial. If you can see that, it is 0.48. 0.48. I know it can be kind of hard to see because your all screens are probably a little bit smaller. And so 0.48 seconds for trial 2. All right, and then we will go on to trial 3. Last one. All right, so for this last one, we had 1.2 seconds. 1.2 seconds. So you can go back into Amplify and put your second. So if you would like to see all 3 trials for both balls, you can see them here. And so for trial 1, 2, and 3 for the ping pong ball, we had 0.79 seconds, 0.48 seconds, and 1.2 seconds. Okay, if you need to get this down, write this down, type it out. I'm going to give you about 20 seconds to do that if you have not already. If you have not calculated them yet, make sure that you calculate them and find the speed. Make sure you find the speed. All right, I am going to go back into my Pear Deck presentation. And so we are done with that investigation. You guys would have done that in class with a partner. This one was always fun, just because you're using that plunger and putting a force on the golf ball and the ping pong ball. So we completed our investigations and we should have recorded our results. All right, for those of you that have found the speed, what did you observe in this investigation? For those of you that have found the speed, make sure that you find the speed. What did you observe in your investigations? All right, looks like I've only got 2 people starting to respond. So make sure you find out the speed of each of the trials and then come back to me. All right, make sure you're answering on Pear Deck, guys. Make sure we're answering on Pear Deck. So once you get done with an Amplify, make sure you come back to the Pear Deck presentation. All right, so the velocity and distance a ping pong ball and a golf ball can travel. The ping pong ball goes faster because it takes less time and has less mass. The ping pong ball had the greatest amount of speed. It's faster than the golf ball. All right, this one right here, we applied the same force to each ball. We had 2 different balls. We had a ping pong ball and a golf ball. So we did not hit it harder. We had 2 different types of balls. All right, so I'm seeing a lot of the ping pong ball is traveling faster. Somebody here had pointed out that it takes less time and has less mass. So I really like that one. All right, so we have a vocab word. So some of you had mentioned the word mass, and that is exactly what our chapter is talking about. So we're talking about force, velocity, and mass and how they relate to each other. And so when we're talking about mass, we are talking about the amount of matter that makes up an object. I think this is the only thing that you need to put in your digital notebook. So go ahead and make sure your digital notebook is up and put this word in it. So mass is the amount of matter that makes up an object. I will go ahead and put that in the chat as well for you to look at. If at any time you guys need to go back to the investigation, it is in Canvas on today's module. It's labeled investigation. It's highlighted in red. So you click on it and it'll take you to a screen that you guys saw, just like the the one on Pear Deck with the 6 different videos. All right, so mass is the amount of matter that makes up an object. All right, so question for you. Which object would have a greater change in velocity if you exerted the same strength force? So a toy car, or a full-size car. Which object would have a greater change in velocity if you exerted the same strength force? A toy car, or a full-size car? All right, go ahead and choose one. Make sure you're responding in Pear Deck. Looks like I got about half of you guys responding. Make sure you are responding in Pear Deck. This should be a multiple choice option. All right, perfect. So the object that would have a greater change in velocity if you exerted the same strength force is obviously the toy car, right? That toy car is tiny, doesn't have much mass. A full-size car is giant, right? Much bigger than our little toy car. Now, think about it this way. Which pod would have a greater change in velocity if you exerted the same strength force? A less massive pod or a more massive pod? A less massive pod or a more massive pod? Remember what mass is. I know those pictures look literally the exact same, but we do not know how many asteroid samples are in each. Okay, so make sure you respond to that question in Pear Deck. It is very similar to our last one. All right, so we know that the toy car is less massive than the actual car, right? So which one is going to have a greater change in velocity if you have the same strength force? All right, we have some confusion here. So if the pod is less massive, that means it has less mass. It doesn't have as many asteroid samples in it. It doesn't technically mean that it's smaller. It just means it has less mass. The more massive one has more mass. Right? So if we go back to this last question, the toy car had less mass. This big car, the full-size car, had more mass. So if we're talking about it in terms of the pod, which one has a greater change in velocity if you exert the same strength force? Still getting people that are saying more massive. Thank you. All right. So we're going to look into this a little bit more. We're going to use a simulation. So the force and motion sim to investigate how the same force affects the velocity of objects with different masses. All right, so we're going to review some details before we get started on this. We are going to continue gathering evidence to answer this question. So if the same strength force is exerted on two objects, why might they be affected differently? And so the sim investigation has two parts, all right? Part one, you guys are going to investigate how the same strength force affects objects of different mass that are not moving. So their initial velocity is 0. They're not moving when you start. Okay? Just like the investigation that I did, the video that I had, my objects were not moving. So that's what we will do in part one. Part two, you guys are going to investigate how the same strength force affects objects of different mass that are already moving. So that means their initial velocity is not 0. It's more than 0. All right, so what you guys are going to do in that analyze mode, so you have the build, the run, and analyze. In the analyze mode of the sim, you can observe the exact change in velocity. So remember what we did in our last simulation investigation? We looked at the analyze part. So we looked at that change in velocity. So that is where you will get or find that out. All right, so go ahead, open this. This will go over the exact instructions that you need to have. Okay, so I'm going to click on this. If you want to look at my shared screen, you can. If you just want to listen and be on Amplify, then that is okay as well. All right, so you have, it looks like 10 different directions. But those are going over exactly what you need to do in the simulation. Okay, so you're going to open up that force and motion sim. You're going to select the 2.1 motionless objects. 2.1 motionless objects. And that is up here at the top left. Remember that we did these missions for 1.5. Now we're doing 2.1 motionless objects. And you should see this screen if you're looking at my shared screen. All right, the next thing that you're going to do is press run and then press play to begin. All right, you're going to press run and then it should be playing already. So you'll press play. Okay, so this is what you have in the run. You guys are probably just going to have to keep going back and forth between your instructions and the simulation, which is totally fine. I think you guys are okay with it. I think you've done it before. We already know the initial velocity is 0. So we are going to prepare our force. Okay, prepare force. And so what we are going to do is we're going to apply some type of force, whatever force they tell us to apply. Okay, so right here it says use the arrows in the force panel in the bottom right corner of the screen to set up a force on object A. And then instruction 6 says you're going to do it for the other objects as well. And so if you scroll down just a little bit, it'll give you the mass, it gives you the initial velocity of each object, and then it tells you how many clicks you need to have on each object. Tells you how many clicks you need to have on each object. All right, so it says 4 clicks to the right. And so what you're going to do is you're going to make sure you have object A selected. You're going to do 4 clicks to the right. Next, you need to have object B selected. You need 4 clicks to the right. And then you're going to do the same thing with all of the other objects as well. All right, my next instructions will tell me to press exert force, and then I will analyze those results. Okay, all you're doing is putting that change in velocity here. You're putting the change in velocity. So once you exert the force and then go to analyze, you will see that change in velocity. So the change in velocity, I haven't started it yet. So all of these numbers say 0, but the change in velocity will be all the way over to the right-hand side. You'll see start, current, and then change. So you will need to record that change in velocity in the table. All right, once you're done with that, you're going to answer the question, which object's velocity changed the most, and then you will move on to the second part of the simulation. So these objects are moving. All right, go ahead, go through that. I'm going to give you guys about 7 minutes to work on this. I know that might not be enough time, but I want to stop us before class ends. You may have to work on it for homework. I want to stop us before class ends so that I can tell you about the exit slip. Okay, so we will come back here at 11:02 so we can have just a few minutes to wrap up. So what I want to go over, I'm going to go back to our Pear Deck presentation. I'm going to remind you guys about these two claims that we have. So remember, there are two claims about what could have happened to this pod. So claim 1 said the thrusters caused the pod to move in the opposite direction. And claim 2 says the thrusters only slowed the pod, it didn't stop. The pod hit the space station, which made it bounce and move in the opposite direction. All right, so normally when the thrusters fire, the pod will stop, but this mission was a little bit different. So if we know that the thrusters may not be our problem, the thrusters were acting the same way that they always do, we can ask this question to ourselves for claim 1. If the thrusters on this pod exerted the same strength force as thrusters on other pods, what else might explain why it moved in the opposite direction? All right, for claim 2, we can ask ourselves this question. If the thrusters on this pod exerted the same strength force as thrusters on other pods, what else might explain why it crashed into the space station? All right, so we got to think about those because the thrusters were acting the same way. All right, so keep that in the back of your head. You guys need to make sure that you complete and submit the weekly check-in for lessons 1.6 and 2.1 on Canvas. Okay, so make sure you do that week 11 weekly check-in. All right. The extension links are still the same if you would like to take a look at those. If any of you guys ever do take a look at those, please let me know what y'all think. But make sure that you get this weekly check-in done, and if you did not finish your 2 simulations on Amplify, make sure to get those done as well. Okay, that is all that I have for you guys today. Have a great Wednesday, and I will not see you guys until Monday. All right, bye guys.